Are they grade 9 natural science students? And in today's lesson, I'm going to look at how to balance chemical equations. Now, we have to look at what you've done last year to understand a little bit about what we have to do this year. But really, it is super simple. Ooh, let me just fix that one. It is actually quite easy to do. And we need to go back to the start and understand that everything on the periodic table is a pure substance, right? You remember that. You know that a pure substance, basically all matter is made out of elements. And a pure substance, basically, that's made out of elements, and compounds are pure substances. So when we look at molecules of elements, we need to understand that some elements on the periodic table form molecules of elements. And you've learned some molecules of elements can be seen or known as diatomical molecules, meaning that they've got two little friends that as soon as you take it from the periodic table and you start using it and it's trying to bond chemically with one another, they are going to always pair up. And the 7 diatomic molecules of compounds are things like hydrogen, oxygen, iodine, bromine, all of those. So what I think we need to start with is we are going to look at how water is formed. Now, you all know that the molecule for water is H2O. Remember, this little number there, that is known as a subscript. And if we were to say the amount of molecules that I have here, at this time we have 1, then this little number here would be a coefficient. Right, so when we are looking at how water is formed, you all know that we can look at it and break it up to 2 atoms, right? We've got atoms from hydrogen that we're working with and atoms from oxygen that we're working with. Now, when we say I'm working with hydrogen, I look at hydrogen and I look at oxygen and I say, hey, if I take hydrogen from the periodic table, I know it is a diatomic molecule. So I'm giving it a subscript 2 because it cannot go on its own. And the same with oxygen. It is unstable if it does not have a little friend with it. Now, even though we are using the plus sign, we need to understand that this is not like mathematics, it is chemistry. So we need to understand that our product forms afterwards. So we need to go and have a look and say, hey, my reactants, when hydrogen reacts with oxygen, my product is going to be water. So I need to figure out, is this a balanced chemical equation? In order to do so, I can go and check it atom by atom. So I look at the amount of hydrogen atoms that I have on this side is 2. The amount of hydrogen atoms that I have on that side is 2. For now, I can see hydrogen is not an issue. Then I have oxygen. On oxygen side, on the left hand side, my reactants, I've got 2. And then on the product side, I only have 1. Now you have to go and think, what can I do to make sure that it is equal on each side? So in essence, what I have on the left hand side of the reaction should be the same as what I have on the right hand side of the reaction, because this is a chemical equation. We need to see that it's balanced. So now what times 1 will give me 2? Obviously the answer is 2. So I cannot put the 2 there. I need to times it with the whole thing. So you are going to have an invisible little bracket here and there, and you're going to put a coefficient of 2 here. But do you now see that your coefficient of 2 also influences your hydrogen. Okay, so hydrogen times 2 equals 4. 2 times 1 is 2, so we have 2. So this side I have now balanced out. But because I've done it on this side, I need to do it on that side. So oxygen is no longer a problem anymore. However, hydrogen has become a problem. On that side, my product side, I now have 4. On the left hand side, I need to check and see, hey, what can I times hydrogen with to get it to 4? 2 times what gives me 4? 2. That gives me 4. So I have to put it, a little invisible bracket around the whole thing. Put a big coefficient with it. Now, an easy way for me to remember where what number goes, or what I call each one, if you look at the little number here, the little one is called a subscript again. Do you see that it is below the size of the letters? So it's almost like a submarine, it's below. Then coefficient, co means equals. It is the same size as the other one. Now, let's have a look and see, is this a balanced chemical equation? On the left hand side, on my reactant side, I can see I've got 2 times 2 is 4 hydrogen atoms plus 1 molecule of oxygen gives me 2 molecules of water. So 2 molecules of hydrogen plus 1 molecule of oxygen gives me 2 molecules. So in essence, to write it out as a nice word equation, I can see here 2 molecules of hydrogen plus 1 molecule of oxygen gives me 2 molecules of water. You all know the symbol for water is H2O. Right, this is a word equation. That is a balanced chemical equation. And let me show you what the picture equation for this will be. We can take that away. We can take the balancing out. And then an easy way to represent it, let me just get that cleaned, is the following way. So let's say water, we all know, is for every 2 hydrogen atoms, let's put the H's inside, we're going to have 1 oxygen. Okay, but this is saying, hey, we've got 2 water molecules, so let's put another 1, 2, and a water molecule, oxygen atom there. All right, so the arrow. Now let's put oxygen, looks like 2 little eyes now, and we're going to have hydrogen, 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 hydrogen. So 2 hydrogen molecules plus 1 oxygen molecule gives me 2 water molecules. Right, I hope this makes it a little bit easier. In the next video, I will have a look at another type of equation, but for now, quickly just look at this and focus on this video. If you enjoyed this video, give it a thumbs up and remember to subscribe. I'll see you guys in the next video.